Hey there, Ashley. Hey, happy Friday. That's totally fine. Happy Friday. So we'll get started in a few minutes here. Even if it's just you and me, we'll still do the workshop and I'll just record it so that it's, there's still a video out there. All right, I'll just give one more minute. All right. What's up, snowmobiles? Good to see ya. Yeah. So, yeah, I was just telling Ashley, even if it's just us three, I'm still gonna get started. And then yeah, so we're just gonna do the workshop, and I'm still recording it so that other people can still see it later down the road. So it's still helpful regardless. And I think today's gonna be a pretty chill day. It's Friday. Just we're gonna all relax and have some fun. So it should be good, and the topic shouldn't be too bad. Share my screen. Let me just make sure I'm recording. Yep. Okay. Cool. All right. Good morning, Calquin. Calquin. I saw that you were in the Minecraft server. Isn't it lit? Yeah. Yeah. Andrea and I built like a spawn point for the Minecraft world, so I was laughing so hard last night. Okay. All right. Cool. Got some sponsor already? Yeah, exactly. Yeah. So basic beasts, goated goats, and what is it? Dugout dogs are all going to be sponsoring some packs and NFTs. So people that so what we're actually going to be doing is we're going to be doing a bunch of different events, I think. So like we're going to have people like find like one event we're going to have is we're going to like hide like signs around the map. And if you like find the sign, then like you get like a float and you'll get like certain NFTs and stuff like that. Yeah, so you can totally play with the PC. That's what I'm gonna be playing with, actually as well. So you can play on a Mac, Windows, whatever you want. All right, I'm gonna get started. So welcome everybody to workshop 4 out of 6. It's interesting because I had mentioned that this boot camp was only gonna go for 3 weeks long. And I said that during week 2, you should cover all of chapter 3 and half of chapter 4, but that's probably not true because chapter 3 is really dense, and so is chapter 4, actually. So what I think I might do is today, instead of going over the rest of chapter 3 and half of chapter 4, we're just going to finish chapter 3 so that we like limit the scope of what we're actually doing. And yeah, so we're just gonna do chapter 3, and then maybe we'll like extend the boot camp a few days, or like maybe even a week, so that we have a whole other set of workshops. So yeah. All right. So chapter 3, day 4. In the previous chapters, we went over like resources. So resources are different from structs because they can't be copied. They have to be moved around. They're more secure, stuff like that. And in addition to that, we went over references. So references basically allow you to like talk about a resource without having to actually move it around everywhere, right? So today we're going to be talking about resource and struct interfaces, which are, a pretty important topic as well. I use these pretty much all the time. So yeah. So just to start out, I think it's really helpful to read like what this section, and then we can start jumping into code. So it says interfaces are very common in traditional programming language. There are two main things interfaces are used for. One is it specifies a set of requirements for something to implement. And two, it allows you to only expose certain things to certain people. So we're going to be talking about both of these today. And I think this image is pretty helpful because it shows you that resources and structs, they implement interfaces, right? So this is the diagram we're going to be referencing throughout today's workshop. All right. So let's go ahead and make a new contract called test, like that. And let's go ahead and make a resource called profile. Why not? We like profiles. And in the profile, we'll put like an ID. We'll put a name. And we'll put a favorite food. Right? Boom. So this is a profile about a user. Now, all of what I'm doing right now, this is all defining a resource and initializing its fields. So we should know this already based on the previous days. And if you don't, it's basically just, defining a resource that's like a container. Here are the fields, and then we're going to initialize the field. So self.id equals, let's just say self.uuid, right? Because we like to use the UUID. Hold on, this has to be a UN64 because the UUID is UN64. We can pass in a name. So we can make the name like the string, and we can say favorite food is also a string. And so that way, that allows us to initialize some of these variables to some initial state, right? So just like this, self.favorite food equals favorite food. Boom. I didn't put the equal sign because I'm an idiot. Okay. So, and then this, I forgot to put the capital F. Cool. So we just defined a simple resource called profile that has an ID, a name, a favorite food. We initialize the ID to it, the resource's UUID, and we pass in the name and the food like that. So is this good so far for everybody? This is just like, the resources in Cadence. And hey, BZ, good morning. Well, I guess a good afternoon for you.
Good afternoon. Sorry, I'm late.
No, don't worry about it. Yeah, so this is just a basic resource. Cool. So let's actually, we're just gonna be playing around inside the contract today, because this is where I think it's easiest to understand what resource interfaces are actually doing. All right, cool. So what we can do is, let's go ahead and say public function, create profile. And let's, open up some brackets here. And so what we can do is we can, create a profile and store it inside of this variable called profile. So that profile, we're going to create a new profile. And what we're going to do is we're going to make the name, let's just make the name snowmobiles. And the favorite food, snowmobiles, what's your favorite food? So we can put it in this resource. Burgers. Oh my god, I would love a freaking burger right now, and it's only 9 in the morning. Okay, so we put in burgers for the favorite food, and we store it inside the profile like so. Cool. So what we can do to sort of help us out is we can like specify the type of this profile just so that we can read it, right? We don't have to do this, but we can just do it so that we know what's going on. So this has a type of @profile, right? And again, we don't need this, but this just helps us to sort of see what the type of this is. Awesome. So down here, let's just destroy profile, right? So we know that we're not going to do anything with it. We're just going to destroy it. So in the middle here, what can we do with this profile, right? Well, we can log like profile.id. We can log profile.name. We can log profile.favorite food. And all of this should work totally fine. So if we deploy this contract, right, let's go into a transaction and let's refresh the page. And let's just say import test from OX01. And we're going to basically just run s.createProfile. So if we send this transaction, look what happens. It logs 0, it logs snowmobiles, and it logs burgers, right? That's just because, that's what we put in this function. And then it just destroyed the profile. So this is just some basic resource stuff, right? We're just reading some information about the profile. Cool. So now let's introduce the concept of interfaces. So if we scroll down a little bit, the section where it says using interfaces as requirements, it says resource interfaces are defined with the resource interface keyword. Cool. And for the record, everything I'm talking about right now, I'm talking about resource interfaces. If you're wondering about struct interfaces, it's literally the exact same thing. It's just that you do them with structs. But so totally same concept, by the way. So with resources, we can make something called public resource interface, and then let's call it profile public, like that. So what we just did is we defined a resource interface called profile public. And inside of here, we can put some basic things that profile has to have in order to work. So let's just put like and stick with me for a second. This may be confusing, but we can put public let ID, right? Let's just put ID and let's put a name. Okay. So basic stuff. Now, if what we can do is remember in this diagram that resource interfaces implement a interface. Resources implement an interface. So the way that they implement them is you do this syntax. You do colon and then profile public, just like that. So now profile, what this code is saying is that profile implements profile public. Now everything worked out, right? There's no errors. Everything is fine. But what happens if I was to put public let crypto poop Boolean? I don't know. I just put the random stuff. Now look what happens. It says resource test profile does not conform to resource interface test.profile public. Now, why is that? Well, if we scroll up to what is an interface, remember I said it specifies a set of requirements for something to implement. So what this is saying is that anything that implements profile public must have an ID, it must have a name, and it must have a crypto poop. And it must have all those types as well. So it has to be the exact same thing. Now, the reason it's complaining is because profile doesn't have a crypto poop. So we have to add a public let crypto poop here that is a Boolean. And of course, we just have to initialize it now. But you get the point that now it's okay, right? So now it's totally fine because profile has all the things that profile public says. So that's just an example. So I'm going to get rid of this now. But you can see that, right? So that's cool. Now we're going to talk about the second one, which it also allows you to only expose certain things to certain people. So inside of our profile here, we log the ID, the name, and the favorite food, right? Now let's create another function here called create profile, or let's just call it create public profile, like this. And so what we can do is we can do the exact same thing here. Let's do the exact same thing, but this time, let us restrict this profile to a profile public, and let's see what happens. So the way that you do that, the way that you reference a public resource, or the way that you reference like a resource interface on top of a resource, is you do this little syntax. You do the curly braces, and then you put the name of the interface inside of here. So let's just do profile public. So look what happens now. This type, we basically just told this type that it's a profile resource that's restricted to profile public. So look what happens now. We can log the ID, we can log the name, but we can't log the favorite food. and it says member of restricted type is not accessible, favorite food. So why is that? Well, it's because we don't expose favorite food with the profile public interface. Even though it exists inside the profile, it doesn't exist in the profile public. So we can't log it. But, you know, how would we, does anyone have any guesses of how we would fix this error? Yep. And I see Snowmobiles is typing too. But you're totally right, BC. Exactly. Yep. So what we can do to fix this error is we can actually expose the favorite food in the interface. So if we say public let favorite food, the string, up, now it's totally fine because now we can log the favorite food here, right? So awesome. Now I just want to show you that not only the names have to match, but the string has to match as well. So if we put like Boolean, this isn't going to work because it's a different variable. Hey, Skyon. Okay, cool. So that is, you know, an example of not being able to access certain data if it's restricted to a resource interface. So let's scroll down and just let me make sure. I'm pretty sure that's everything I wanted to cover from this day. Yep, I did the same thing with this complex example. Yeah, okay. So let's just yeah, so let's just do one more example, but let's do it with a function. So inside of here, let us do a new function. So let's add a function called public function change name. Say the new name is a string, like that. And we can say self.name equals the new name. Now, of course, we have to make this a variable because we have to change it. So cool. Now, what's the problem here? So I think I just have to maybe refresh the page. I don't see why this would give us error. Yeah, okay, so this is still giving us problems. We can comment this out, right? So let's comment this out. And resource. Oh yeah, because this has to be a var now, right? So even this has to match. So this also has to be a var. Got it. Okay. So does this mean create new admin resource is an anti-pattern? What is it? So there's just a oh, I see. It's just a question for after. Yeah, BZ, I'll come back to that. So I can answer that more in depth. Plug function on a contract that creates. Oh, I think that's just talking about the fact that like if you expose an admin, I think that's just a very obvious statement. I think it's just talking about the fact that if you expose a public function with an admin resource, anyone can get it. All right, cool. So now we included a function inside of our resource called change name, right? So what happens if we try and call change name in this one, right? Where it's just a profile. Well, we can do, you know, profile dot change name, and we can pass in a new name. So let's pass in Pucks. I see Pucks here. Hey Pucks, by the way. Okay, so we pass in a new name, Pucks, right? So this works because we have the change name function inside the profile resource, right? But what was to happen? You got me. Yeah, I sniped you out. So what would happen if we tried to change the name on this type right here? So let's go down here and try it. So let's do profile that change name, and let's pass in who else in here? Willy Blue. Hey Willy. Okay, so look what happens here now. It says member of restricted type is not accessible. Change name. So look, it even works on functions as well. So we're not allowed to you know, we're not allowed to call change name here because it's not in the public you know, interface. But the way that we could add this is we could add the function signature to the profile public. So let's do that now. Let's say public function change name takes in a new name that is a string, and it doesn't return anything. So this is how you add it to an interface, right? Is you add, you know, you don't do any implementation because that's not, you know, you can't implement anything in an interface. You just give the function signature. So now down here, now the change name works totally fine because it's inside of the resource interface. Awesome. So you may be wondering like why this is helpful and how we can use this as a security layer in our smart contracts. And the truth is that all of this comes into play when we start talking about account storage next week. So definitely hold on to these understandings for next week, because this is going to really come into play when we start talking about account storage. But it's also cool, to start thinking about like how we can protect our resources, right? Because, if we're sort of looking at these functions, if we wanted to return a profile to the user, we could return a profile that allows them to do anything. But, we could also, I don't know, like return a profile that's restricted to a profile public, and then the user would only be able to do certain things then, right? So, we could fix up these errors really quickly. So that, we're actually returning them to the user. Now, of course, this isn't really that secure, right? Because anyone can call this function since it's public. But, that sort of like gets into the security of stuff. So definitely, if you are interested in this sort of topic, wait till next week because it'll be really important when we start talking about account storage. All right. So that should be good to go. You should have enough knowledge to do the quest now. So that should be it. So what we're going to do for the remainder of this workshop is talk about access control. So to be fully honest with you, I think that access control is probably the most confusing topic we're going to cover. So we're going to spend the rest of the workshop talking about it. And there's a good chance that you all just feel completely lost. That's fine. I think partially the reason why it's going to be so hard to do this is because access control is not only difficult, but it's also like really difficult to explain on my end. As always, I think the best way to sort of learn this is to literally load up a playground example and start experimenting with all this on your own. But yeah, so it just a heads up that this might be a little confusing, this chapter, but we're gonna definitely try our best to do some cool stuff. All right. So in order to do this, we're going to be using this chart to basically do everything related to this, right? Because this chart is going to be your go-to for everything access control related. So let's actually, I'm thinking about maybe I even want to start over. Yeah, so I'm going to start over here with a whole new contract because we're going to be talking about some pretty different stuff. Okay. So boom, fresh start. So now we're inside of a contract test. And we're going to be talking about access control. So what is access control, first of all? Well, throughout this entire course so far, every time we define a variable, like a number, it's an integer, and every time we define a function, do stuff, every time we do one of these things, I always told you to put public, right? And public was sort of like our default to go. And so far, all that we know is public allows anyone to look at it, right? Now, the truth is that public is actually something called an access modifier. So in Cadence, let me just initialize number, by the way, so that it doesn't give us errors. But in Cadence, the thing is that, this is called an access modifier, and it's only one of 4 that you can put, or actually it's one of 5 that you can put. And public, what public means is it allows anyone to read it. So this is saying that, okay, we're going to name a public variable named var, name number. So in a script or a transaction, anyone can read this, but we can't change it. So let's try and show an example of that. So if we deployed this contract, right? And let's actually, inside of do stuff, let's just log like we did stuff like that. Let's go ahead and deploy this again. So inside of a script, let's try and read a number right here, right? Let's try and read this number. So let's go to a script and let's actually return, we named it an int, right? So let's try and return it inside of our script. Oh, hey, Bam. No worries about being late. It's totally fine. So import test from OX01, and Bam, you already know all this already. So you're the cadence master. So inside of test, let's try and read our number. So let's return test.number. Let's execute this. And of course the playground is being buggy. LOL. Okay, so if we execute again, boom, there it is. So it is 1. So look, it allowed us to look at the number, right? Which is pretty cool. Now, the next question is, can we just update number directly? Well, if we go to our transaction, let's go inside of our transaction and let's try and say test.number equals 2. And it doesn't work. Cannot assign to number. Field has public access. Consider making it publicly settable with public set. So we're going to get into this in a bit. But this is to show you that with a public variable, you can read them from anywhere, but you cannot change them anywhere else in the broader scope. So what I mean by that is because number is defined right here, you can change it anywhere inside the contract, which is technically below it, but you can't change it anywhere above it, which is outside the contract, right? So when I talk about above and below, this is where things get a little confusing, but you have to think about where the actual variable is defined. So right now, number is defined at the top level of the contract. So above it means anywhere outside the contract, and below it means anywhere inside the contract. But if we talk about something like a struct, like hello, right? And inside the struct, we have a public variable called number, just like that. Above this means anywhere at the top level of the contract, right? And below it means anywhere inside the struct. So you have to think about where things live relatively, because that's where access control really matters. So we're going to do a bunch of examples together. Now, one more thing. So we just talked about public in terms of variables, but what about in terms of functions? So let's refresh the page again. So we had already deployed this. So let's try and call this function called doStuff. So let's go into here and let's say test.doStuff. And you'll see it works totally fine. So we're allowed to do this. So if we send this, it says we did stuff, right? So if we go to our diagram here, let's actually look at what we're doing. So for the purposes of this workshop, we're going to be ignoring everything from here to here because all of these have the let declaration. And so it's a constant. So it doesn't make sense to talk about access control if it's a constant because it has no write scope, right? Because with constants, you can't change the value of it. So we're going to be focusing on the variable stuff. So that sort of minimizes our thing pretty well. And so yeah, okay, so let's go here. Cool. So these variables right here, this is talking about, what we're doing right here, right? We have a variable named number. So if we look at this, right, let's look through. So access self, no, that doesn't look right. Access contract, that doesn't look right. Access account, no. Oh, here we go, pub. That's what we're using. So it says the read scope is all, but the write scope is current and inner. And that's what I was just telling you. So the way that we can read this number is anywhere, literally anywhere, because it is public, right? And it says the read scope is all, but the write scope is current and inner. And like I described, current and inner is anywhere that at this level or below it. So we can't change it in the transaction. So is everyone sort of with me so far on what I'm talking about when I say like below and above and current and inner? Like, does that sort of make sense so far? Okay. Okay, cool. And also, while I'm doing this, by the way, let me pull up one other thing that's going to be pretty helpful that I forgot to do. I'm actually going to add this camp. I totally forgot to do it. Yeah, I totally forgot to add this as well. So can I open this up somewhere? Okay. So we're just gonna focus on this one. Okay. All right, cool. So everyone's with me so far. Awesome. All right. So what I was showing you here, this is for variables. Now, what about for functions, right? What about for functions? So this is a public function. So I forgot to add this. I'm gonna add the screenshot to the course. But this is talking about functions. So the access modifier and the access scope. So public is all. So we can call this function from literally anywhere we want, right? Awesome. Now, one other thing I want to mention is that the public keyword is the exact same thing as typing access all. So if you ever see, it's giving us a bug, but if you ever see access all, it's the same exact thing as pub. Like literally the same. Now, of course, I don't know why you would ever write access all because it's very like verbose. Just type in pub and it's the same thing. Cool. So let's get a little more fancy now. So what if we wanted to actually change, what if we wanted this write scope to be all? Well, what was it telling us in the transaction, right? So test.number equals test.number plus 1. So it says, hey, consider making it publicly settable with public set. So what is public set? Well, here it is. Var. Oh, here's public set. So the read scope is all and the write scope is all. Oh, cool. So if we make this a public set, just like that, refresh the page. If we make it a public set like that, we can redeploy the contract. And now inside of our transaction, oh, there's no more errors. So let's go ahead and read it first. So it is, oh my God. So we can read it and it gives us 1. But look, now we can try and update it. So, okay, we updated it and now we go back and now it's 2. Boom, so we updated it. So public set, to be honest with you, this is very rarely used. Very rare. Because this is, I mean, obviously not secure at all. Because if you make something publicly settable, anything can change it. So you have to be very careful with what you make publicly settable. And oftentimes, you know, oftentimes you'll get that error, like, oh, consider making it publicly settable. And, you know, most of the time I would not follow their advice because that's a very dangerous thing for you to be doing. Okay. So that is public set and pub, right? Now, let's get into some more interesting things here. So what if we wanted, okay, well, hold on. I got to think really hard about what I want to do next because this can get confusing. Oh, and by the way, you'll notice that public set doesn't exist for functions because it doesn't make sense to change the definition of a function, right? It doesn't make sense to do that. So public set does not exist for functions. Oh, and one more note, by the way, that while I'm talking about public, with a contract, it's always public. Like this is never anything but public. And same thing with resources, right? You may be wondering, well, can we make like a resource, you know, a different access modifier? The answer is no. This is always public. Same thing for structs. It's always public. So never change these. It's always public. Okay. All right, pretty cool. So what if we wanted to make it so that not everyone could call do stuff, right? So actually, let's add another function here, and let's do like xx-axis. We don't know what we want to put there yet. Function, contract. Let's just name it contract only. So log only the contract can call this. All right. So we want to make it so that only the contract can call this. Well, let's go to our, you know, sort of access modifiers here. So let's go through here. You know, public makes it so that anyone can call it. Account makes it so that the current inner and other contracts in the same account can call it. And access contract makes current inner and containing contracts. So look at this one. This is what we're going to use. Access contract. So if we go in here and say access contract, now only the contract can call this function. So if we tried to go to a transaction here, let's refresh the page, and we tried to say test dot, look, it doesn't even, there's no even option, but if we wanted to, let's just try contract only. And look, value of type, oh wait, what? So we refresh the page maybe? Did I spell that right? Contract only. Maybe it doesn't even know about it, right? Yeah, okay, so it doesn't even know about it because we can't call it, right? So I'm guessing. It should give us a different error, like not accessible, but anyway, this is fine. So you'll notice that we can't even call contract only here because this is only callable from the contract. So anywhere inside the contract, we can call this function, but not outside of it, right? And quick note about access account. So access account is also pretty cool. You'll notice that it's very similar. It's current inner, right? Current inner. The only difference is that access account is other contracts in the same account can also call it. So if you don't know, one account can have multiple contracts in it. And in the playground, we only ever deploy one contract to an account just because that's how the playground works. But in a real scenario, you can deploy as many contracts as you want to an account. And so access account makes it so that anywhere in the same account, we can call it. So even in other contracts. Whereas access contract is only in that literally like one contract, right? So that's pretty cool. So to show you an example of this, let's actually inside of do stuff, let's log we did stuff, and then let's call contract only. Okay, why is it? Oh, it's because I didn't redeploy this contract. Maybe that's why. Wait, this is Oh, am I stupid? Oh my God. Okay, so it's self.contract. Okay, sorry. Wait, is that why? No, that's still weird. Okay, so anyway, inside of a function do stuff, we log stuff, and then we do self.contract only, or this is the same thing as saying test.contract only. So boom. So we put this function here, and now it's giving us an error. It's cool. So you can see that it allows us to call contract only inside the contract, right? So if we deploy this, we go back to our transaction here. You can refresh the page. Oh, okay. Now it's giving us the correct error. So it's saying cannot access contract only. Function has contract access, right? So that's a good error now. But let's actually try and do test.doStuff. Okay. So let's run this transaction. And it says we did stuff, and then only the contract can call this. So you can see that it correctly ran this function as well. Yay! Super cool. All right. So this is basically like the beginnings of public set, public and access contract, which are, probably the most important. But we're going to go over some more complex examples to talk about the other ones as well. So let me actually look at what I did in the course to try and figure out what I should do here. Okay, yeah, this is going to be hard to explain, but I'm going to try my best. Okay. Trying to think of what to do so that I don't lose everybody. So put X in here, test function. Okay. All right, so what we're gonna do now is we're actually gonna add a public struct here. We're just gonna call it container. And we're gonna put some stuff inside this container to show you what we can access inside and outside this container. So instead of storing a number here, we're gonna store a container, which is a struct. And like I said, you might get confused by this, but it's okay. Just try and stick with me as much as you can. Okay. So cool. So let's actually get rid of this contract only one. Let's get rid of this do stuff one, just so that we have a very clear understanding of what we're working with here. So we now have a struct called container, and we store the container at this level, right? So what we can do is inside this container, let's actually do so BZ says, I wouldn't mind learning more about Access account. Neo used it. I think Beartech wrote this. Oh, yeah, no, I'll totally go over Access account in a sec here. Okay. So what we can do is inside this container, let's do a public let X and make this an int. Let's just initialize X to the self.x equals 0, right? So what we have here right now, let's deploy this contract. We have a container. Oops. So we have a container that is stored at the top level of the contract. So what we can do is, because this is public let X, the read scope of it is all, right? So we can read it here and outside the contract. So if we wanted to, instead of a script, we can log test.container.x, right? And if we execute this, then boom, see, we can read it totally fine because the read scope is all. Now, what does current and inner here mean, right? Because public has a write scope of current and inner, right? Boom, right here, current and inner. So current and inner means here, and then anywhere inside here. So we can't, we can't change X outside here, right? We can't do that. So for example, if I had a public function called change X that tried to do this, it tried to do self.container, so it's referring to this container, .x equals 2, it won't let it, because we can't change X out here. We can only change X in here because of the current and inner scope here, right? So is everyone okay with this? Because this is pretty important to understand why we can't change it out here. Right, because this, like, the current inner scope is here and then inside the struct. Okay. Cool. So if anyone's okay with that, and you look, you can even say that it says, you consider making it publicly settable, but you know what, we're not going to listen to Cadence because that would be, pretty, actually, we could even make it this far, but, that would be pretty scary to make this publicly settable. So let's comment this out for now. Let's comment this out. Right, actually, we can just delete it because it's never going to work anyway. Okay. So let's try and change X inside of here. So let's actually make a function called change X. I should have just copied and pasted that. And that just says self.x equals 2. Now, see, this is totally fine if we refresh the playground again because it's buggy as absolute hell. So boom. So self.x equals 2. Cool. So this is totally fine. Oh, hey, Bulldozer. Do you have any questions? Oh, and he's gone. Rip. That's sad. Okay. So we can change x in here, right? Now, what? He was here and then he's gone. Okay. So this is cool. Now, what if we wanted to do something else? So what if we wanted to say, x here, we only want x to be readable inside this container. So what we can do here is do something called access self. And what access self will do, and by the way, access self is the same thing as typing private. So you can type, priv, or you can type access self. Now, what this means is that not only the write scope is current inner, but the read scope, right? We're here now. The read scope is also current and inner. So this means you can't even read x outside, like up here, right? So if we wanted to do a function here called public function read x, we can't even log self.container.x because it has, private access. It's even telling us that. So we can't even read x anywhere outside the struct, right? So that's like a little thing about that. Now, let's do one more example where we do, let's try and do an access contract function called readx, right? So we're just playing around with different modifiers and we can return self.x and this returns an integer. So this function right here has contract access. So we can call this anywhere inside the contract, even if it's above it. So what we can do is to read x now, we can say self.container.readx. And this is totally fine because we can call it anywhere inside the contract. So you may not know it yet, but access contract functions are probably one of the most powerful things in Cadence. And there's a lot of useful patterns that I use with access contract functions that people haven't sort of grasped yet. Of course, because I'm sort of a Cadence genius, obviously, right? But this is, once you really get into the depths of access control, you will find that access contract is probably one of the most important things in the language, or access account. All right, so with that being said, I sort of just went really deep into access control. What we're gonna do now is spend the rest of the time here. We're actually gonna go over the quest together. So we're gonna completely do the quest together. So let's actually copy and paste the quest here. Boom, and let's copy and paste the last part into the script. So let's deploy this, please. Playground, please. So hard to teach with buggy playground. Okay. So now we're inside of the contract, right? So it's called some contract, and there's a bunch of stuff here. Now the point of this quest, I actually think it's pretty fun. It's almost like it's sort of like it's like a puzzle almost. So playground was built in React. Coincidence? I think not. Use Svelte. That's what I've learned from Andrea in the past couple of weeks. Yeah. Svelte is the way. Okay, so yeah. So this is sort of like a puzzle. Now, what we're going to be doing is you'll notice that I have a struct right here called test struct, and I define the struct right here, right? And inside of this struct, we have 4 variables. So we have a publicly settable one, a public one, an access contract one, and an access self. And we have 3 functions, a public one, an access contract one, and an access self. And then we have 4 different areas to experiment with what we can read and write. So we have area 1, area 2, area 3, and area 4 is inside the script, right? So pretty cool stuff. Okay, so let's deploy this, please. Nice, huge. Okay. The playground actually seems more buggy. No, yeah, something happened in the last update that made the playground a lot worse. Yeah, it was already pretty bad, but something happened in the last update that like completely ruined it. Okay, so anyway, I won't crap on the playground anymore. So let's actually go to area 1, right? So if we look at the quest, it's saying the quest is For today's quest, you'll be looking at a contract and a script. You'll be looking at 4 variables and 3 functions defined in some contract, right? So that's what I just showed you. There's 3 functions and there's 4 variables. In each area, so 1, 2, 3, and 4, so here's area 1, right, area 2, and so on, I want you to do the following. For each variable, tell me in which areas they can be read and in which areas they can be modified. So write scope, okay? So let's actually stick with the variables right now. So let's go to the first area. Boom, we're in area 1, okay? So which of these variables, so let's make a category called read scope. So which of these variables can be read? Does anyone have any guesses? So right now, I can actually make this a little bigger so that we can see everything. So can people still see this? So we have a struct. We have 4 variables, right? Does anyone have any guesses on which ones we can read inside of here? This is inner, by the way, because it's all in the same struct. All 4. Totally correct. So you can read all 4 of them. So all of them. So you can read all of them here because they're all within the current scope. So that's always readable, right? So we could even say, you know, like log self.a, log self.b, log self.c, and log self.d, right? They're all readable. Awesome. Now let's talk about write scope. So which of these can be written inside of here? PC, you already know the answers, you rat. BC, so it's actually funny because this is the same quest that I gave BC a couple months ago during Fast Forward, so he already knows the answers. And he also is he's a pretty experienced cadence developer at this point, so he's a trickster over there. But yes, the answer is all of them, right? Because if we look at the write scopes, right, they're all at least current and inner, so we can always write them, right? So if we go down here, we can say a equals a or self.a equals self.a plus 1. Wait, what is it? Oh, it's a string. Oh, equals like la whatever self.b equals self.c equals and self.d equals okay? So boom. So the write scope, we can write all of them totally fine. Okay? So take like a mental picture of this because we're going to be deleting this soon. So write scope is all of them. All right, so mental image taken, boom, done. Okay, so that's area 1. Cool. Now let's talk about area 2. So area 2, okay, so this is, okay, things are getting weird, right? Things are getting very weird. So that was area 1. Area 2 is in a totally different resource inside of a function, okay? So we're getting a little strange here. So how do we even approach this? Well, just for the record, we actually store a test struct at the top of the contract. So we can reference this struct down here, okay? So let's talk about read scope. So does anyone have any guesses about read scope? This is just in terms of variables, by the way. So BC isn't allowed to talk. Does anyone have any guesses about the read scope here? And this is the only time that I'm going to wait just to see if people have answers, because I think this is probably like the most important lesson to be interactive with. Also, Bam, you know the answers too. Let's see if snowmobiles can get it. All 4 again? All right, so let's actually so let's think about this. So BC changed his name. So inside of this read scope, like let's think about this for a second. So A, right, has read scope all, right, because it's publicly settable. So we can read it from this test struct totally fine. B has public, so it also has read scope all, right? Look, they both have read scope all here. So we can read it as well, right? But look at C and look at D. So C is containing contract. So is this still in the same contract? It is. So we can read C as well. But what about D? D is access self. So access self means the read scope is current and inner only. So the only way we could read D is below this where it's defined. So only in functions inside the struct. So we can't read D. Does that make sense, snowmobiles? So we can only read A, B, and C here. So you'll we'll just, for the sake of time, let's just try to do let's try and do some contract. What the heck did I just write? Some contract dot test struct, because that's what's defined at the top here, right? And then let's try and do dot D. So let's try and log this. And you'll see has private access, so we can't do that, right? But we can like log C because it's in the same contract. We can log B because it's all, and A because it's all, right? So boom, that's read scope. Awesome. So let's go to write scope now. So what about write scope? Does anyone have any guesses for write scope? I know you can do it. Oh, here comes Skyone to save the day. Gold star to whoever can get this right. Close, Calcoin, but no cigar. Who's gonna claim the gold star? I guess A. And yep. So Willy Blue and Bam, you're both correct. Boom, gold stars to both of you. Good job. So yes, the answer is A only. And the reason for I wish I could read what this is. Let's go to Google Translate. What did this person decide? Hello, Cocklam. Hello. Hi. I'm happy to have you here. So I'm not sure who Cocklam is, but that's the person. That's like a sick name. I don't even think they're in the. I don't think they're in the voice either. Anyway, so yes, so the reason that we can only write A here is because again, let's look at these variables, right? What does public have? Well, public has a write scope of, right? So write scope of current and inner. They all have current and inner write scope. The only one that has all is public set. So again, these three can only be written in the current and inner scope, which means below where they're defined. So only in functions that would change them inside the struct. Whereas publicly settable can be changed literally anywhere. So we can change some contract. Oh my god, what am I typing? What? Some contract dot test struct dot A equals right? Whereas if we try to do this for B, it wouldn't work. C doesn't work, and D doesn't work. Okay? So is everyone okay with this? Snowmobiles, are you okay with this? Is everyone all right with this? Yep. Okay, good. Good. Perfect. All right, so that is area 2. Done. We did area 2. Now, area 3 is a little easier, actually. So area 3, it's not even in a resource. It's just at the contract level. So at the top level, right? So does anyone have any guesses for this one? What is the read scope here? And remember, we can reference the structs right here. Any brave souls in the chat? Who are the brave souls? Oh, we got Kelcoin typing. Okay. Here comes Kelcoin to save the day. So read scope. Close, Kelcoin, close. There's one more you're missing. Calcoin does love the AB pair. Really close. Really close, Calcoin. Good job. That's funny. ABC then. Exactly. So Calcoin, I'm curious. Do you want to explain why it's C? Like, do you know why it would be C here as well? And think about it. It's because, let's go back to the access modifier. Access contract, right? The read scope includes containing contract, right? So is this function in the same contract? Exactly. So that's why we can read C here, because it's in the same contract. So down here, we can read A, B, and C, right? And just to test it, let's do some contract dot test struct dot A equal let's log this, right? Let's try and log it. So boom, that works totally fine. What about B? Yep, works totally fine. C works totally fine, but D does not work fine at all. And again, that's because D is access self, the same thing as doing private. Although I don't know why I never write private. I don't know why. Weird. But this is only readable in the current and inner scope, which is below where this is defined. So that will not work. All right. Cool. So is everyone good with that? Hopefully yes. Okay. So let's go on to the right scope now. So does anyone have any guesses for the right scope here? What can we write right here? So cubic ray says D. So we can't write D because D actually is the most restrictive one. So D is access self. So we can only write this in the like below where this is defined. So this is actually the most restrictive one. Oh, you mean A? Yep, exactly. Yeah, I knew you meant A. Okay, so right scope is A, exactly. So A, because of the fact that, you know, the right scope is public set, so we can write it anywhere outside this struct. So we can, if we wanted to, we could say, you know, some contract that test struct that A equals whatever. Boom, it's changed. Eat it, right? Boom. All right, cool. So that is area 3. So let's go. So let's go to a script now, and this is where area 4 is, right? Ooh, area 4. Okay, tricksy, right? So we're in area 4 now, and let's talk about the read scope and write scope here. So read scope. So what does everyone think the read scope is in area 4? And I'll go back to here for a second. Remember, we can this is public, so we can always view this, right? A and B. Look at you, snowmobiles. Okay, you're getting it. Nice. Yep, fire emoji under that one. So the reason for that is, so snowmobiles, do you want to explain why it's not C? I mean, D is relatively obvious, right? But do you want to explain why it's not C? While you're doing that, I'll put the answers here. Because it's not inside the contract. Exactly. So if we did, let's try and log some contract dot test struct dot A. Boom. It's giving us a weird playground error. But yep, works totally fine. B works totally fine. C, has contract access. So not allowed. And then D, obviously, is not allowed because it's private access. All right. So that is read scope. Perfect. Okay. Anyone want to make any guesses on the write scope? Hint, hint. It's the same sneaky little variable that's been the same the whole time. A, exactly, Willy Blue. Look at Willy Blue. Boom, with the answer. Nice. Okay, so if we do some contract dot test struct dot A equals lots of weird stuff. Boom, works totally fine. And then obviously the other ones won't work because they're not publicly settable. All right. So you guys completely crushed area 4. Now, before we leave, we forgot the functions. So we have to do the functions now, okay? So let's quickly, I know you guys can do it, but let's do the functions now. So let's go back to area 1. Anyone have any guesses? So this is public function, contract function, and private func. Anyone have any guesses for the functions in area 1? Which ones can we call here? And I guess what I'll do is I'll call this one 1, I'll call this one 2, and I'll call this one 3. One question: can we really write with a script? Aha! Look at Bam. So Bam discovered the trick. I was hoping someone would get that. So right here, I was trying to move on to see if anyone would catch it, and look at Bam, the sneak. So right here, we all said that the right scope was A. Does anyone want to tell me why this is actually wrong? Why is it that we can't actually write A here? It's sort of a trick question. Think about where we are right now. Aha, look at Willy Blue, it knows the answer. So not quite Calcoin, close. See, like in practice, right? Some contract.teststruct.a, right? It actually allows us to do it, right? If we refresh the page, like it's actually fine. But why does this not make sense here? Script is read only, exactly. So in a script, we actually can't change any state. So it actually doesn't make sense here. If I was in a transaction, right? If I was in a transaction and I did like area 5, let's do this. So if I was in a transaction and we did this, right? Then this is totally fine, right? This actually makes sense. So if we import some contract, right? So this is correct because we can change data in the transaction, but it's a trick question in the script because we can't change anything here. So just wanted to point that out. Okay, so I know we're over time. So quickly, does anyone want to list the functions we can call in area 1? And you can just name them 1, 2, or 3 based on what I did here. Any cadence legends in the chat? We got Cubic Ray flying in with the answer. 1 and 2. Close. So we can definitely call public func, right? Sorry, it's called self.publicfunc, right? We can definitely do that. We can also do self.contractfunc. All of them. Yep. So that's right, Ashley. So we can do all of them. So if we do self.privatefunc as well, this is totally fine. Because access self, if we go to the functions one, access self is current and inner. And we are indeed in the current and inner scope because this is defined at the struct, right? This is defined at the struct level. And then this function, right, is defined as well. And then this is technically below this private func, right? Because we're within the scope now. So it's totally fine to call private func here. So the answer is all of them, right? Boom, that's area 1. Awesome. So Cubic Ray, does that make sense why we can call private func inside of here? It's inner, exactly. Yep, totally correct. All right, so does anyone want to go over area 2 now? So just as a reminder, this is in a totally different resource, right, inside of a function. So which ones can we call in here? And remember, we can reference the struct because it's defined up here. 1 and 2, exactly, Ashley. Perfect. So just if we wanted to, we could say some contract dot test struct dot public func. Boom, totally fine. If we tried to do contract func, also works totally fine. And if the last one we wanted to do is private func, this will not work, right? Doesn't work. Now, I just want to point out, I want to point the importance of this out. Out of all my time of developing on Cadence, one of the most important things that I've learned is how crucial access contract functions are to Cadence. The reason I say that is because they unlock so many different potentials for you to develop in Cadence. In this example, let's say we want to change A outside the contract, right? We can't do that with access contract because access contract write scope for a variable is only current and inner, right? But with a function, you can call access contract anywhere inside the contract. So oftentimes, a really important pattern in Cadence is that if you want to change a variable outside in the containing contract, but you don't want to risk exposing it to the public, you name the variable public and then expose an access contract function that changes it, and that it'll change it inside the remaining contract. So I can't stress enough, and I actually on my YouTube, I think I'm going to make an entire video about the importance of access contract functions. That's sort of a side note. So access contract does not exist in Solidity. No, it doesn't. So, well, I mean, I guess technically it does. It's different, I guess. Like that access contract doesn't really make sense in Solidity. But sort of, yeah. Like it is pretty unique in the Cadence format. Okay, awesome. So let's go to area 3 now. So what can we call inside of here? Hint, hint, it's pretty similar. And this, we're almost done. So we're still in the contract. One and two, exactly. We can call 1 and 2 here. Again, because public can be called anywhere, access contract can be called anywhere inside the contract, and access self can only be called in the current inner scope. Yep, exactly. So boom, that's area 3. And then the last one, let's go to area 4. Any guesses for this one? Last question. Nice, snowmobiles, exactly. So do you want to explain one last time why we can't call a contract function inside of the script? Because it's the only one public, the other two inside contract itself. Yeah. So this one can only be called inside the contract, and because we're in a script, we can't call it here. And similarly, for access self, we can't even call it in the contract. We can only call this one in the inner scope. So obviously, we can't call it in the script either. All right, so that concludes. If you understand that, then you've technically completed the quest for chapter 3, day 5. So next week we're gonna dive right into chapter 4. I was mentioning at the beginning of this workshop that originally I intended that you would also complete half of chapter 4 by the end of this week. I realized that that's probably not possible because it's just very confusing. So I'm thinking of extending the bootcamp maybe another week or so, just to give people some time. Chapter 4 is going to dive right into account storage, which is going to be another major topic, because this is where things actually start to become real. So once we talk about account storage, stuff starts to get pretty legitimate, because that's real contracts interact with account storage. And so far we've just been playing around in the playground, but this is where things get like really interesting. And if you're coming to Cadence from a Solidity background, you're gonna probably be confused here, because this is a totally new concept. But anyway, if you have made it to this point, you've technically completed chapter 3. So round of applause to all of you. Woohoo! Woo woo woo! You did it, and that concludes this workshop. So thanks everybody. Hopefully it was helpful. And also, I really encourage you to come to the town hall tomorrow. So tomorrow, Saturday, at 9. Wait, what is it? I always forget the time. I think it's 8 a.m. PST. So tomorrow at 8 a.m. PST, we're having the Emerald City-wide town hall, which is the big get-together for everything inside of Emerald City. So we're going to talk about Emerald Academy. We're going to talk about these workshops. We're going to talk about Float. We're going to talk about Pre-Mint. We're going to talk about the Minecraft Challenge. We're going to talk about Emerald Token. There's a ton to cover tomorrow. So if you're interested about Emerald City DAO, really recommend coming tomorrow to the town hall. And also, if any of you are good Minecraft builders, please let me know, because we will love to have you build in our Minecraft world, like a spawn point for everyone. So if you're a good Minecraft builder, please let me know. So yeah. Jacob taught awesomely. Thank you, Pucks. So great to have you here. And yes, Ashley, it will be recorded. So it will definitely be recorded. All right. Good job, Cadence Legends. And if there's no more questions, I'm saluting my screen right now. So I'll see you all in the next one. Peace, peace. All right, YouTube. Peace, peace.